Hello, in this first lesson, I will explain to you a bit of foundation of the computer visions, what is the main component of the computer vision, and how we can utilize the computer vision concept in order to solve some sort of the real world application. So first thing first, computer vision is the science and technology of machine that sees. So in general, computer vision means that we have a computer that equipped with perception sensors in order to perceive information from the environment. And then the challenge or the aim is that how the computer can utilize the received information, the perceived information from the environment in order to translate something that is meaningful to the computer to understand. So for the image data, the perception can be taken from many forms, such as from the video sequence, depth image, laser range finders, medical scanner, and etc. So this is some of the basic component of the computer vision that we usually do in order to translate or in order to perceive or understand about the surrounding. So the first component is the camera system. So this is the you can say that the optimal or the usual sensor that can be utilized in order to perceive information from the environment. So it can be either for the 2D image or for the 3D image. So the second component is the scenes or the object of the interest. So it is important that if we use the usual cameras, the light must be present. That either it can illuminate the object straight away or it can illuminate the environment so that camera can perceive the shape, the texture of the object so that it can be understand better. So one of the main heart of the computer vision is the computer. So this is the processes in which it will process all the fed input image that is obtained from the camera sensors, and then later on how it can be translated to something that human can understand. So let's say for this case, if I see the image, I see the bottles, I see the wine glass. So how we can ensure that the computer will understand the same thing? So one of the issues in order to ensure that we can make sure the computer can understand about the environment is that how we can interpret or how we can ensure the information, the rich information present in the image can be segmentized, can be put into the smaller portion so that the computer can understand the things better. So let's say for this particular image, we just see in general the picture that was taken near the sea. So how we can make sure that the computer will understand this is the picture taken in the sea. Second thing is that the location of the car. So we have two cars in the right side and then we have a single car in the left side. So how we can translate that coordination to the computer understand format. And then the next part is how far is the building for this case. So means that we know that from our human naked eye perception that the building will be a bit far than the white car location. But how to translate that thing into the notation that can be understood by the computer is something that is quite challenged. So why it is challenge? So I give you some simple examples here. So in the left side here, this is what we usually see. So in this case, we see that the train that is collide from its track. So this is what we see, which is we can interpret the image quite easily based on the look at the image straight away. However, the issue for the computer is that computer only sees numbers in terms of the arrangement of arrays with some sort of the depth of the pixel value. So usually for every image, we call this part as the pixel. The pixel will be ranging from 0 to 255, in which this is 255 will be white, whereas 0 will be black. So it will be depends on the dimension of the image. So let's say if our image dimension is 220 and then times 240, So for this particular case, we have with, let's say for this case is the 3-bit image, which is RGB. So in this particular case, the computer need to process 320 times 240 times 3 number of information in order to ensure that it can translate. This is the condition in which the train that is under collision or out of the track. So this is what we try to do for these semesters, in which based on the image that was later on translated into the numbers, series of numbers, sequence of numbers. So how the computer can utilize or process that thing into something that will be understanding by the computer in terms of the location, the coordination, in terms of the texture, shape, what is happening inside the image. So that is the thing that we try to do for this semester. So this is some general concept on how computer interpret the image. So most of the conventional way will be based on scan the image entirely. So by using, in this case, we use some small window that we call as the kernel, and then slide the kernel throughout the image, and then only extract object of interest from the image for the higher level processing, such as for understanding the object, understanding the what is inside the box, and etc. So the conventional way, so this is most of the common way, but it's actually very time consuming because you need to test the bounding box with multiple size, multiple location, and etc. So the current method in order to perform this operation, or we call that thing as the efficient way, is by using the region proposal method. Region proposal means that you don't have to scan the entire image in order to extract object of interest. So some of the well-known method is something like SSD, single shot detectors. Second is based on the bounding box degradation. And then part of the YOLO, you only look once algorithm, is to extract the object of interest from the image in a very fast way. And then second, once every location or once object of interest location was extracted or thrown out from the image, then what is actually inside of the extracted portion. So there is the higher level processing in which it will understand better about the image that the system has been extracted early. So vision is the multidisciplinary field. So why it is multidisciplinary? Because of, in order to dive in order to do a research or project in the computer vision, you need to know multidisciplinary field such as the mathematics, the machine learning, artificial intelligence. So why everything is related? Because of if you just able to extract or you just perceive information from the environment without the knowledge about the artificial intelligence, you don't know. Computer does not know what is actually inside of the image. Is it image important? Is it image something that need to be processed later on or whatever? So another thing is that computer vision is widely used in many robotic applications and also in the signal processing field and etc. So this is some sort of the examples of how the computer vision used in, let's say in this case, is in the safety area, in the health image, to process the mammogram image, for the security, surveillance, let's say trigger an alert when detect some sort of the suspicious activities inside of the shop. For entertainment, create a cartoon. For fun, let's say for gaming, one of the prominent or one of the previous example is introduction of the Kinect cameras. And then access is something like we have smartphone. So let's say how we can use smartphone in order to geotag our location. Let's say we see some landmarks in the unknown area, so we just capture the picture of the landmark, and then it will Google what is the landmark is all about and where is it the location, or what is the information about the landmarks. So this is information that was extracted from the Computer Vision and Pattern Recognition Conference from 2019. So this is some sort of how the vision system was actually used nowadays. So if you look at the pie chart here, so the most dominant application is in the deep learning area, in which it was constitute about the 24.4% portion of the application. So the first application is deep learning, and then the second one is more on the recognition, which is the detection. Detection means that we detect object of interest inside of the image and then localize the location. Categorization means that we give some sort of the image and then it will classify this type of image without giving some knowledge about the exact location. So this is some sort of the application that is widely used nowadays. So because of the current trend of the computer vision will be based on the deep learning or artificial intelligence, in which how we're able to make sure that the computer can replicate the human capabilities. Because of we as a human, we can see everything and then we can understand about the environment. But let's say we go to somewhere place that is quite new. So for that particular thing, there might be something that we don't understand. So we, in our learning process, we see the thing, we can Google the information, and then later on we have the knowledge about the object of interest that we do not understand. So computer will try to replicate the same things, especially from the deep learning perspective, in which in some situation you can increase the knowledge about the deep learning structure based on train with the new type of image, new type of information, and then it will memorize the thing, and then you can use such information to predict something that is quite new, and then it will give some prediction or probability about that particular object. So in the next sequence of slide, I will give some sort of the example of how the computer vision used nowadays. So this is one of the example of how the computer vision was used in order to classify the image. So in this case, this is the platform of the convolutional neural networks, which will be utilized in order to recognize the type of image. In this case, is the cat. So convolutional neural networks works by selective activation of the neuron based on the input image in order to finally or eventually give the prediction whether this is cat or not. So the same thing with this application, in which it will be utilized by using the convolutional neural network structures to predict the incoming image, whether it is a car, whether it is a plane or not. So we just feed the image straight away, and then some series of feature extraction here. You can see there is some black and white image here, the grayscale image. This is the stage where the features was extracted from the input image, and then later on, finally, this is the prediction layer, in which it will give the probability of every class of the trained object, and then the highest one is most likely related to the input image. So this type of application is more on the detection. So in comparison with the previous one is the classification, classify the car. This one is the detection. Detection means that we perform two stage or two state of information. The first one is classify the information inside of the box, and then secondly give the exact location. So usually the location will be tagging with respect to the two coordinate here, xy from the top left and then xy from the right bottom. So this is another example, which is the vision will be used in order to predict or to visualize how the surgery should be happen. So this is some sort of the augmentation reality, in which so the surgeon will know the area that he or she can do the operation to ensure that it will be located exactly in that particular area. So the same thing with this part. This is something like the auto claim system, in which let's say when accident happen, so the insurance agent just need to capture the image, and then it will predict the severity of the image before can suggest the appropriate amount for that particular situation. Optical character recognition is one of the well-known applications. So in this example, it was used in order to recognize the handwritten. So the model will be based on LINET. So LINET is one of the first model of the deep learning or convolution neural networks. So some of the application is for the license plate recognition. So automatically can actually give permission to enter some compound of the area. So word length is some of the combination of the image processing, data augmentation, and then artificial intelligence in order to ensure that if you don't understand some sort of the words, text, we just can capture that thing. So in this case, this is another language, and then it will translate that thing directly. This is a Spanish to English translator. It is very instant. It will overlay the output of the translated words directly to the camera. Okay, so I just move on to some sort of the application. You can read all the details. You can click on the links to know better about some sort of the application for the vision, industrial robotic, and etc. So this is the thing that I want to highlight for our lecture. So in general, there are some words that quote that image tells you 1,000 of words. So the word is really true for this particular image, and I will show you how. So in this case, vision is the source of the semantic information. We just see the single type of image, but it contains a lot of the information. So for instance, for this case, so in this mesh, we have the portion of the area that related to the sky. This is the building, flat, banner, bus. So this is one way that we can interpret the image. But there are another way. So in this case, the condition. So this is the outdoor image. So this is the city image. So the traffic congested, or the request is the traffic will be quite okay. So there is another way to interpret the image, and then the same thing. In this case, this is the slanted area, and then this is the vertical object, non-rigid moving object. So many things that can be interpreted from the single image. So depending on our situation, or depending on what we want to see from that particular image, we can actually interpret the things in the thing that we can understand better. There are some challenges in the computer vision in order to develop applications. So I will just highlight some of the few that can be found. So some of the example is this case. The first thing is based on the viewpoint variation. So in this case, we have three different type of face. So how the computer can understand this is actually belongs to the face, or this is actually the object of interest in terms of the face. The second thing is illumination variation. So we have three same image, but we just put a different illumination like source. This is in the center, so this is on top. Also, this is from the left side, in which the right side, in which we have some shadow here. So this treating, how we able to train the computer that this is the same images. It only corrupted, or it only illuminate with the different type of the illumination from the different angle. So the next thing is in terms of the scale. So in this case, we have the picture of the human that carrying the laptop, a small person with a bigger laptop, and big person with a smaller laptop. So how we can train the computer to know that this is actually human, and then this is actually laptop, regardless of the size, or regardless of the dimension. So object deformation means that let's say when the horses are running, so means that the body shape of the host will be different in every sequence. So how we can ensure that computer understand that this is the picture or this is the type of object that belongs to the host when the host was running. The occlusions means that we have some object here, and then there is some object in front of the this object of interest, so that how we can ensure that the computer will understand that this is the image that is belong to the host, this is image that is belong to the human, then this is actually the image of tree. So this is one of the challenging example that you will facing when you develop computer vision application, in which there is some situation that the background image texture will be almost the same with the foreground texture. So this will be quite challenge. How we able to extract, let's say in this case, I just interested in terms of to detect the crack area. So how we can do that thing, how we can train computer to ensure that it will prune out the object of interest only. So for the object intra-class separation means that all these things was actually belongs to the cluster of chair. So how we able to tell the computer that this is also chair, we call this thing chair, this is a chair with just a different type of variation and etc. For the local ambiguity, let's say we have this type of image. From our naked eye, it is also quite hard in order to interpret what is inside the image. So this thing can belongs to many locations of the image, somewhere in here or in here or in here or another location in here. So now the issue is that the same situation, the same question to the computer, how you can train your computer to understand the thing much more better. So this local ambiguity belongs to the which part. So the same thing with here. So let's say if we develop some application to train to detect the human location. So let's say the human, let's say wearing some sort of the picture that also contain very uh, how I call this thing. Let's say quite colorful pictures. So how the computer can tell that this is also human, only for this particular case, human just wearing a very colorful picture. So it's challenge or opportunity. So this is up to you for interpret the things. But in general, if some of the area is quite challenged, then there is maybe the area that you need to dive in, because maybe not a lot of person in that particular area. So this is some sort of the application of the region segmentation. It's quite very challenging how we can extract the area here, another area here, and then later on, based on the extracted region, we can do many things such as the classification, such as object interpretation, and etc. For the future of the computer vision, so as can be seen from this report, so it was stated that the future or this industry was around 2.73 billion in 2017, and it is expected to reach the 25.3 billion by year of 2023. So a lot of opportunities that we can put effort in the computer vision areas to ensure that we are not losing the train. We are on track, we are on the right track. What is the area in computer vision that people dive in, that the research, what is the direction of computer vision that we should put ourselves in. So according to this report, so it was stated that in every minute, so user watch around 4 million YouTube videos and then post around 46,000. So this is every minute. So means that there's a lot of opportunities in computer vision area that you can dive in. A lot of research that you can do in the computer visions in order you can fit the end user demand. I just highlight back in terms of this thing. This is some of the top 25 keyword of application that latest trend in computer vision from the computer vision pattern recognition conference, one of the top-notch conference in the computer vision. So this is the area that perhaps you need to put your effort right now in computer vision field, so that you will be in the right direction with other majorities under the computer vision domain. So if you like to do some research in the computer vision, so this is some of the top-notch journals and then conference in the computer vision areas. So in order to make sure that you can dive into this area, so you need to ensure that you have a very good foundation in terms of the programming, in terms of the basic mathematics for the application-wise, and etc. So that's all for my first part of the lecture. So thank you very much.